Hello, everyone. I wanted to spend some time summarizing what you've just seen in What is Life. Brian Cox begins his movement in the film by sort of discussing what humans have conceived life is. For him, the idea of religiosity, we call it the spark, the mythical flame that animates beings, beings in which have souls that transcend time. And he says he has an alternate explanation for what life is, but it behooves scientists to really, explain it, legitimately to others if we're going to, kind of go fly in the face of the religious interpretations. But where Brian really doesn't delve into, and nor really was it his task in the film, is explaining why humans need to have this sort of mythical religious interpretation. And it has to do a lot with our capabilities. Like if you take your dog or another animal around you, they have real cognitive limits and they don't have a great deal of what we call displacement. And displacement refers to our ability to refer to ourselves, events, and other people and things in time and space, and able to project them in time and space. So we can easily project our own death. So it's not very pleasant. I mean, I can in my mind think of, oh, I'm going to die someday, and then that will be the end. I mean, I can actually visually see it and actually feel it. And that is a really terrifying sort of thing for a human. Now, dogs don't have that. They can see other dogs die, they can see other things die, and they can realize that they could be killed. But barring the fact that something outright kills them, they will live forever. So they run around their lives, trying to prevent from getting killed so they can live forever. That's the trick. That's the difference. They don't visualize their actual death. The amount of anxiety it causes humans and the disruptions in our social sort of fabric is enormous. Thus, we have evolved to have the needs for a mythological framework. We're evolved for mythological imaginations. We adopt mythologies very quickly when we're young, and we live within the framework of those mythologies because they really do reduce anxiety. They're anxiety buffers. Now, getting past that is very difficult because when you're in the world of science, those anxiety buffers, those explanations, those mythologies sort of end. You start seeing a human for what it really is. And we're going to be doing that too. But I'm not going to leave you hanging with this. There is a light. Sorry, I shouldn't say it in the religious frame. A light at the end of the tunnel. That I certainly know that I'm going to live forever, and it has nothing to do with religiosity. And I'll get to that soon once we get to the genetic aspect of the course. But believe me, hang in there. All right. So let's see where Brian's going with this. So he hangs a lot of his arguments on a paper that was written in 1943 by Erwin Schrödinger. And Schrödinger did write an essay, and it's called What is Life? And what's interesting is you can just type in Schrödinger What is Life, and you'll get a PDF. It's free if you want to download that and have a look at that paper. And in this paper, he did argue that part of what life is like the rest of the universe around us. We obey all the laws of thermodynamics. And Brian didn't want to expand it to all of the degrees that Erwin Schrödinger did, but wanted to stay within some simple confines about how we process energy. How we process energy. Energy is a measurable, definable quantity, and all energy is processed through the universe in the same way, through the laws of thermodynamics. Thus, if humans are part of that physical space in the universe, we must obey the laws of the universe. So we must process energy in the same way, and we do. So he talked about the first and second law of thermodynamics, right? First one is energy is eternal, right? It just changes form, but the total amount of energy in the universe is the same. And the second one is known as the law of entropy, the second law of thermodynamics. And that is why the total amount of energy is the same in the universe. What's different about it is over time, it changes form. It always moves from a higher quality, right? In other words, a more organized form. And that also means mass. Everything you see, like around me in this room here, everything is mass, and it's constituted by highly organized units of energy. There's energy is trapped in there. And if I release that energy, right, it will be in a less useful form. In other words, all that matter around me will deteriorate over time. And it does. You watch things in your life fall apart. Once you make something, it begins to disintegrate and fall apart because the energy is being transformed right into the environment. And normally it dumps out as other forms of matter, which are less organized, or ultimately they can be exhausted as heat. And everything stockpiles the end as heat. So he looked at the way, humans process that energy and convert matter, which is the food which you eat, which is a highly organized form of energy, and then convert it to a lower organized form of energy. All right, that's one thing. Now, the next thing he was looking at is the type of energy that we actually use to power ourselves and do this. And in this sort of argument, he was trying to get us to the point where we could see that our connectivity to all other life on the earth. Many religions let humans see they're important in the whole scheme of the earth and the universe in different ways. Many see humans as very different animals, and everything around us is substandard and lower, and we're somehow the divine users and manipulators of all things. Everything's been given to us. But in reality, Brian was trying to show us that we are deeply connected, not only in an evolutionary perspective from the beginning of the Earth, but how we process energy. We all do it in the same way by utilizing proton gradients. Right? So, in other words, our cells, we have little pieces inside of all of our cells, right? And they're called mitochondria. They're little factories, and their job is to actually create proton gradients. They take protons and pump them across their membranes, create electrochemical gradient. And as the protons move across, they create electrical energy, which goes into other processes, creating more compact forms of chemical energy, right? These phosphates, ATP it's called. And then we use the ATP, these phosphate bonds, and we release the energy from the bonds, and we literally drive our bodies, all the muscles, everything. And that's just not in humans, that's in all the other life forms on Earth. They all do it in the exact same way, all in the same way, which means we come from a common ancestor. And that move towards where that common ancestor is and where we think it was, the last common ancestor, the very, very first one, the very, very first one. This occurred, and from what we know now, just about 3.9 to 4 billion years ago. Only about 600 million years after the formation of the Earth, very early forms of life have actually arose. And they didn't arrive from outer space. They were developed in situ here on the Earth because this Earth is probably meant to have life. I mean, the entire universe is meant to have life. It's not really separate from the organic world. It's integrated together. And it occurred as soon as these proton gradients were engendered in the first primitive oceans. As the Earth was getting rid of its residual energies, it's hot gases rising, up through what we call hydrothermal vents. The hydrothermal vents were relatively alkaline. There was a deficit of protons on the inside. And the ocean water was slightly acidic, which means there's a gradient, a higher amount of protons in the water. And those would flow through these hydrothermal vents. And we see it today. The hydrothermal vents are still there. They are relatively small in proportion versus the millions of square miles of these vents in the early Earth oceans. Now, as the electrical currents were flowing, we have tremendous amounts of organic molecules. We know amino acids, organic molecules were produced in the Earth's early atmosphere. And we have all the raw ingredients. And it was just a matter of time, statistically speaking, for the very first organisms to appear. And even the cell membranes, in which are wrapped around all of the 14 trillion cells in our bodies, are naturally formed. They're called micelles. These phospholipids, they actually naturally occur in nature. They're empty. But once you have those, in these hydrothermal vents, it's just a matter of the connectivity of getting the right combination of the organic molecules until life begins to seed itself. The next trip was life sort of freeing itself from these hydrothermal vents and finding a different energy source. And that took quite a while. We call it the boring billion. Roughly a billion years goes by until we start seeing the very first organisms that are capable of photosynthesis. And then life on Earth really takes off because these photosynthetic organisms begin to release oxygen to the atmosphere, and everything turns into a flame. Life begins to evolve. And we'll be looking at that process later on. So that was really what Brian Cox was trying to get at. And he also made this last point. And we're not quite there in the course yet, but it's a very important one to sort of think about. That for life to be successful, we have to take this pattern of energy, right? Borrowing order from the universe to stay integrated. We borrow energy, right? And eventually we can't stay organized. We have to die. The organization falls apart. What happens? We die. So how life continues this pattern is through reproduction. And it has to be a copy of what we're doing now. We're highly successful at what we're doing, which means we have to copy ourselves and move into the future. We have to do it the same way. And that's through the elegant chemistry of DNA, through reproduction. The heartbeat of our course will be coming up as we talk about how that reproduction process, the DNA has moved on, how even slight changes, as Brian Cox mentioned, even the fidelity is preserved very well in the DNA, but even slight changes in mutation generation after generation can lead to slow and progressive and adaptive changes in organisms through time. And we'll be looking at those methods in which DNA changes itself so we can see exactly how evolution works and in the long run how it does change. So, and all in the film, recognize people like Erwin Schrödinger. Recognize the importance of the way we produce energy. Recognize that energy is eternal, but does change forms from highly organized to less organized. Life processes energy in the same way as every other element in the universe. And life's trick is being able to retain on a little bit of organization for a while for itself, right? Process energy. And before returning all that entropy out to the universe again, right, as we decompose, as we die, pass it on to the elegant chemistry of DNA, hanging on that 5 balance for ourselves. And I think what Brian ends with, I think is very important too, in our search for a life elsewhere, that this process of life that we see here on Earth is probably extraordinarily ubiquitous. But we have to remember that the universe we live in is a vast one. And being able to find the other forms of life may be the tricky point, but most likely they are indeed there. Now, we're going to be revisiting Brian Cox in another film very, very soon. And it's called Why Are We Here? And trying to answer some more fundamental questions, such as where did our universe come from? And we want to do that in biological anthropology because it's one of the things, the nature about ourselves that we have a desire to know origins, not just of the human origin as an evolved species on the earth. At what point did our species evolve? But where indeed has the universe arisen? So we're going to be backtracking towards that point, and then we'll move forward after we have a pretty good, I think, feel for that into human evolution. All right, so let's get to our next section.